4D. The height of the tree in meters, the height, can also be modeled by the function g. Always go slow and careful. Here's something different. This was h of t, meaning the height at different years. Slow and careful. This is the height of the tree. They have an x, where x is the diameter of the base of the tree. So they're saying we can calculate the height of the tree by plugging in the diameter, or here we were finding the height of the tree by selecting the year. When the tree is 50 meters tall, so that would be when h is equal to 50, height, or g is equal to 50. The diameter of the base of the tree, the diameter, is increasing at a rate of 0.03 meters per year. You need to write that down. The diameter of the base, that's x. Therefore, dx dt, when the height is 50, so that's g, we'll say, this is equal to 0.03 meters per year. According to this model here, what is the rate of change? What is the rate of change in the height of the tree? Rate of change of the height. Let's write that down. According to the model, okay, model is g. So according to the model, was the rate of change of the height. So that's dg with respect to time. That means over dt in meters per year at the time when the tree is 50 meters. So I'm trying to find this when g is 50. That's what I'm trying to find. So that looks like related rate, where I have one rate and I'm trying to find another rate. So therefore, I need an equation. So the rates are listed. The equation I need must involve the height of the tree and the diameter of the tree. Because if these two rates are related, then these two amounts are also related. And they gave me the formula that shows how g is related to x. So that's the formula I need to take the derivative of. I'm using the DRED process. I didn't formally make a Daniker's chart, but I basically did. These are the rates in the chart. X and G would be the amounts in the chart. I've read the problem, got all the rates. I've got my equation that uses the appropriate amounts. That's here. And I'm going to differentiate that equation with respect to t. So let's do that. So this is just all explanation again. G is the height of the tree. X was the diameter. We're interested when g is equal to 50. At that moment, dx dt is 0.03. So now I must take the derivative of the equation. So the derivative of g would just be d of g over dt. To take the derivative of this, I have to use the quotient rule. So I take the bottom multiplied by derivative of the top. Subtract the top multiplied by derivative of the bottom divided by the bottom squared. Okay, working that out, 100 is a multiplying constant. So here it is. Now I would be left with dx dt as you see here. 100 times dx dt. Still have the 1 plus x multiplying. Then there's the minus again. I have the 100x again. Okay, here the derivative of 1 would have been 0. Then plus the derivative of x would become dx dt. All divided by the 1 plus x all squared. You get to that spot, you earn 2 points. Okay, we're supposed to find the value of dg dt when g is equal to 50. So I have my formula here. I know the value of dx dt. So I know the value of the dx dt here. That value of dx dt is going to be 0.03. My problem is I don't know the value of the x, the diameter, when the height is 50. But I have a formula where I can plug in the height of 50 and determine what the diameter is when the height is 50. So that's what I'm going to have to do next. This was my derivative again. That was worth 2 points, not 2 more points, just 2 points so far. This box here is not going to earn you any points, but you must go through this process in order to find out that when x is 1, when the diameter of the tree is 1 meter, the height of the tree is 50. We determined that by plugging 50 into the equation for the height diameter equation there. So it's the slogan. We plugged in a height to find a diameter. So we rearrange this equation. We multiply the 1 plus x across. Gets us to here. Then we distribute. And we move the 50x to that side. And clearly x has a value of 1. Okay, the goal of the problem was to find dg dt. At what rate is the height of the tree with respect to time changing when the height is 50? That's what we're trying to find. So we take our formula and plug everything in. dg dt when g is equal to 50 means I have to plug into this formula an x value of 1, because the diameter of the tree is 1 when the height is 50. I don't need to do any computation, so I stop. That will earn me the third of the 3 points. 2 points for finding that derivative dg over dt, 1 point for doing this work to find that x is equal to 1, and then for plugging it in. That would be the final point. You don't have to show this work. You do have to find that x is equal to 1.